Hi, this is Angela Gower-Johnson, and I'm here with Julian Drummond, and we are here to discuss where do sizzling minerals really come from. And I'm going to pass you over to the amazing Julian Drummond.
Hi there. So I got asked to do this presentation at one of our Sizzling minerals meetings. They wanted me to describe how the minerals get inside the plants that are now found in the mine in Utah. So I started going back from the plants and I ended up going back a lot further than I thought I would. So I'm just going to go through the presentation like I did at the meeting, and hopefully you'll get some value from it. So there are lots of scientists who think there was a Big Bang. So not this sort of Big Bang, but more like this. So this is something just showing that there was a Big Bang at zero, if you look down in the bottom left. And within 3 minutes of the Big Bang, the scientists think that all the matter in the universe had been created. And then it took another 380,000 years for the universe to cool down enough that protons and electrons that were whizzing around as a gas, it got cool enough that they could actually form atoms. And what was around in the beginning of the universe was mostly hydrogen and some helium. So this hydrogen and helium that was just a gas floating around in space, it started clumping together. And as it started clumping together, it started to attract more hydrogen. So and the more that got clumped together, the greater the gravity got, and more gathered together until it got to a big enough lump that it started squashing in on itself. And when something's big enough and squashing in on itself because of gravity, it starts to heat up. And that's how the very first suns formed. And that's basically where every element, every mineral that is on the earth that we're made of comes from. So if you were to cut one of these very first stars through its center, you would see that the very outer layers of it are where the hydrogen is. So the hydrogen is being squashed together and it forms a heavier element called helium. Then helium and hydrogen get squashed together and they start forming these heavier and heavier atoms. So we've got carbon, I think there's neon, oxygen, silicon, and at the very center of one of these first stars, iron was being formed. So if we look at a periodic table, so up in the top left, you can see a H for hydrogen, and it's got a little 1 here. And what that means is the atom of hydrogen has got what's called a proton, which has got a positive charge. And it also has 1 electron, which has a negative charge. And the proton is in the middle of the atom, as if the proton is where the sun is, and the electron would be represented by the Earth rotating around the sun. So if you look over at the top right, so the next heaviest element is helium, He, and that's got a small 2 in the corner. So helium has got 2 protons at its center, where the sun would be, and 2 electrons orbiting, so that would be like 2 Earths orbiting the sun. And what this periodic table basically shows is the elements as they get heavier and heavier. So lithium over here below hydrogen, top left, has 3 protons and it has 3 electrons orbiting those protons. Beryllium has 4 protons and it carries on. So carbon, which is the basis of life, has 6 protons, so 6 electrons orbiting. Nitrogen, oxygen has 8. Down here, aluminium has 13. Calcium has 20 protons, 20 electrons. So in these very first star, that's where there are 20 minerals formed, and these are the ones that I saw that were in sizzling minerals. So there's lithium in there, beryllium, sodium, magnesium, potassium, calcium. I think that's scandium, titanium. It's hard to read. Vanadium, chromium, magnesium, iron, boron, carbon, and so that's how those very first 20 minerals were formed in those very first stars. So where do the rest of the minerals come from? Because there's 75 minerals in our sizzling minerals. So eventually these massive, very first stars, they ran out of energy. So they'd used up all the hydrogen. And what happens when a star runs out of hydrogen to burn is that it collapses under its own weight. So gravity is so great, it makes the star collapse in on itself. And what happens is that as it collapses in on itself, it gets so hot that it eventually, there's so much energy formed that it explodes. And that's what scientists call a supernova, is when a star runs out of energy, it collapses in on itself and it explodes. And there's so much energy in one of these supernova explosions that all those elements, those first 20 elements, they all start to collide with each other at such high speeds that they start to form the heavier minerals. So that what we can see here is, so this is the 55 other minerals you're going to find in the sizzling minerals. So all these heavier elements, so the heaviest one I've marked down here has got 83 bismuth, I think, 83 protons and 83 electrons orbiting it. So that's where the other ones come. They come from a supernova. So these are some pictures from NASA that were taken with the Hubble Space Telescope. And what these are, these pillars you can see over on the right. These are basically clouds of minerals and oxygen and hydrogen and carbon that were, when the supernova exploded, they were thrown out into space. And what happens is, over time, these particles and minerals, they all start to gather together. So right now, in these massive columns of dust, there are new stars forming and new planets forming. And so these dust clouds that come from a supernova explosion, they're called nebula. So basically these dust clouds are full of the 75 minerals plus all the other elements there are in the universe. So these eventually condense into stars and planets. So basically a sun like ours forms at the center, and once it gets big enough, it starts burning hydrogen again and starts that whole process over again. And then the other gas orbiting that sun forms into the planets and moons. So, in essence, the Earth and everything on it, including us, all those elements and all those minerals and all those gases were essentially formed inside a star. So we are literally made of stardust. So that's enough about space. We want to get down to Earth and the plants. So how do minerals get from the Earth and the soil into the plants? So what we did at the meeting is we had 3 volunteers come up to try and describe what a mineral is So basically, we had red balloons and yellow balloons. So a red balloon would represent a proton, a positive charge at the center of an atom. And we had a yellow balloon that represented an electron that was orbiting that proton. So we had someone stand with a red balloon, and they held one yellow balloon in their hand, and they represented hydrogen, because hydrogen has one red balloon and one yellow balloon representing the electron. So a second person, we tied two red balloons around their waist, and they held one yellow balloon in each hand. And then we had someone represent the mineral lithium, so that we tied three red balloons around their waist, and we had them hold one yellow balloon in each hand, and they had to kind of balance the third, because it's not easy to hold three balloons. So I need to give you a little bit of complex PhD level chemistry and physics so you understand the next bit. So basically, atoms are happiest when they have two electrons orbiting the nucleus, and the nucleus is where those protons are. So if you imagine, if you are an atom, if you can only hold two balloons, one in each hand, easily. So if you were hydrogen with one balloon, you'd want to get hold of another yellow balloon, another electron. And if you were lithium, because you've already got two in your hands and a third one kind of balancing between them, you're quite willing to give that other electron away, because really you're most stable when you've got two electrons orbiting. So how does a plant attract these minerals? So let's say a plant wants to attract lithium to the roots. So what it does, the plant has a special protein on the outside skin of the root. And what it does, it takes a hydrogen atom, it takes away its electron. So now the hydrogen has no electrons. And if you remember that all the atoms want to have two electrons, that's when they're happiest. So hydrogen, the roots, it takes the electron from hydrogen and kicks it out into the surrounding soil. So now you have these hungry hydrogen atoms that are going to steal an electron from any mineral they come across. So in this example, if one of these hydrogen atoms that's had its electrons taken away from it, if it comes close to a lithium mineral, it's going to take one of its electrons away from it, because lithium is happy with two, and so it has one electron to spare. So lithium now it's got three protons, so three positive charges. It used to have three electrons, three negative charges, but the hydrogen atom's just taken one of its electrons away, one of its negative charges. So now it's got three positive charges at its center, its protons, and it's only got two electrons, two negative charges. So overall, the lithium mineral now has a positive charge. And there's a quirk with water in that the way water's made up, it has a very slight positive and a very slight negative end, a bit like a magnet having a north and south pole. So in this slide, you can see a chloride mineral, which has a negative charge. So can you see these red and blue? This represents a water molecule. So the water molecule, the positive end of the water molecule is attracted to the negative chloride mineral. So this mineral gets surrounded by water. And the same with, so we've got sodium here, which is positive. so it attracts the negative end of the water molecules. So basically, if a mineral has a negative or a positive charge, it gets water attracted to it. So it gets surrounded by water because the water is attracted to the negative or positive charge. And that's how a mineral dissolves in water. It's because it gets basically trapped in a cage of water. So now the mineral's dissolved in water, it's surrounded by water molecules. So all the plant needs to do now, if the plant can draw the water to the roots, the mineral is going to have to go with it. So I'm going to pass over to Angela for the next bit.
Hello, so I'm going to talk to you about hydraphones. So in this picture, you can see a leaf that has little teeth on the edges of it. And on those little teeth, there's these little water droplets. So most plants have leaves that have a thing called hydraphones. And hydraphones are a mechanism for a plant to be able to release water so that it can get the minerals. So a plant, unlike an animal, when it's hungry and needs nutrition, cannot go to its food. It has to bring its food to it. So we already explained, well, Julian explained to you how it draws its food to it by stealing an electron, which then creates a chain reaction that allows water to surround a mineral. So now what it does is it releases tiny droplets of water through the hydraphones on the leaves. And what that does is it creates this really gentle sucking motion that allows the water to gently be sucked up through the plant's roots, bringing the minerals with it. So it releases some of the water that it has already so that it can create this gentle suction that goes up through the roots and into the plant, bringing the minerals with it. So here's another slide that's showing that. So you're seeing the root hair and soil particle and soil water. The water goes through the inside of the root and up into the stem. Now that the water is moving towards the roots, the dissolved minerals have to go with it. So the minerals enter the root cell through a special protein gate on the root's surface. So in this picture, you can see these little metallic balls that are sort of bluey green. And the minerals are absolutely tiny. And what happens is one mineral will go through, and for that little mineral to actually be pushed into the plant, it actually needs 4 more to go through behind it to push the first one through. So the minerals enter the root cell through a special protein gate on the root surface, and the first one that goes through needs 4 more after it to push it through. And we believe that there are different root cell protein gates for each mineral, which is phenomenal. So that is how the minerals get into the plants. Thank you so much for watching our presentation. Bye.